Assalamu alaikum students, my name is Fatalbert and today we are going to complete the remaining numericals of the chapter 11, the acoustic dynamics of sound. Now I'm going to read the statement of the numerical 11.6. So what is the statement and what did the examiner ask in that particular numerical? So for that particular purpose, I'm going to read the statement. A student clapped his hands near a cliff and heard the echo or echo after 5 seconds. So, there's a student. First of all, what is meant by cliff? A cliff is a steep face of rock and earth. It is usually found at the edge or of the sea or a mountain or a valley. Cliffs can form naturally due to the erosion process, weathering, or geological activity like earthquakes. Okay, you got it. What is meant by cliff? There is a student who clapped his hands near a cliff. So, whenever he converted his chemical energy into the vibrational kinetic energy of the oscillating source particle, then the vibrational kinetic energy from the oscillating source particle has successfully shifted towards the neighboring particles of air, and through the chain of the neighboring particles of air, it is shifted towards the cliff. And after hitting the cliff, the sound waves or vibrational kinetic energy in the form of compressions or reflections bounced back from the cliff and started to travel towards the student as well. And that particular process is called reflection or echo of sound. So that particular numerical is actually, you can say that a 90% reflection of the previous numerical 11.5, which you have done successfully. So magnitude of the time taken to hear the echo or echo is equivalent to delta t is equivalent to 5 seconds. So that is the total time taken by the sound waves to travel from the student towards the cliff and after hitting from the cliff and bounce back towards the student as well. So that is the total time taken of the two trajectories. And first trajectory is from the student towards the cliff and the second trajectory is from the cliff towards the student. So that is the total time taken. Okay. And that is not a time taken of one go. That is a time taken of the two go. Means a two-way journey from the student towards the cliff and from the cliff towards the student. So what else did the examiner give to us? The examiner has given us if the speed of the sound is taken as 346 meter per second. So magnitude of the speed of sound in air is equivalent to, as it is the average or approximate speed, so I have written the symbol as P average, which is equivalent to 346 meter per second. Okay. What is the distance of the cliff from the student? We have to calculate the distance of the cliff from the student. Means we have to identify or anticipate the magnitude of one go journey from the student towards the cliff. So magnitude of the distance of the cliff from the student is equivalent to S1. I have used or I have taken the symbol S1 to represent the distance covered by the sound waves during first half of the cycle or the first half of the journey. So that is S1 which we have to find. So first of all, using formula, distance covered is equivalent to average speed multiplied by time taken to cover that particular distance. Put values, how that particular magnitude is derived, and for that particular purpose, we have multiplied the average speed with which the sound waves travel with the total time taken by the sound waves to travel from the student towards the cliff and then after hitting from the cliff towards the student, and we'll get the total distance traveled by the sound waves during the two halves of the cycle or during the two halves of the journey. So we have to calculate the distance of during the first half of the journey or during the second half of the journey. So for that particular purpose, I have to half or I have to divide the total distance covered with a factor of 2. So put values. The total distance covered is 1730 meters. So when we divide it with the factor of the 2, we'll get the distance of during the first half of the cycle or the second half of the cycle, keeping it in mind that the sound waves are traveling with a constant or an average on an approximate speed. So the total time taken during the first half and the second half of the journey will be the same in an approximate manner. Okay. And I have discussed the reason in the previous numerical as well, that the hurdles that we will take the assumption that the hurdles faced by the sound waves during the first half and the second half of the journey will remain the same. Okay, when we divide the total distance covered with the factor of 2, we'll get the answer of the distance of the cliff from the student. So that particular distance is in meters. So that is the end of the numerical 11.6 as well. So I'm going to read the statement of the numerical 11.7. A ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. So that is actually the 100% copy paste or the 100% reflection of the previous two numericals. So I think you have to do it on your own, but I'll do it for you guys for the sake of your simplicity, guys. So without wasting any time, we're contributing to deliver that particular numerical as well. So if the speed of ultrasound through seawater is 1531 meter per second. So here we are 11.7 numerical number given data magnitude of the time taken to detect the ultrasound means it is the total time taken by the ultrasonic waves or the sonic waves to travel from the surface of the sea towards the seabed, and after hitting the seabed the sound waves or ultrasonic waves will be bounced back towards the surface of the sea. So it is a total time taken by the sound waves to travel from the reference surface or the surface of the sea towards the seabed, and after hitting from the seabed to come back towards the surface of the sea. So that is the time taken to travel from here, which is the inception point, which is the surface of the sea, towards the seabed, and then after hitting from the seabed to travel towards the surface of the sea as well. So that is the time taken by the sound waves to travel from the initial position and then end their journey on that particular initial position as well. So the initial and the final positions in that particular case will be the same. So that is the total time taken. So magnitude of the speed of sound in seawater, which is the average approximate speed, is equivalent to 1531 meter per second, with which these ultrasonic or ultrasonic waves or the sound waves are traveling. So we have to find magnitude of the depth of the sea. So that is actually that kind of numerical. We did that particular numerical in the previous case as well. So using the formula is equivalent to average speed multiplied by time taken to cover that particular distance. So by putting values, we'll get total distance covered. For to calculate the total distance covered, we will multiply the average speed with the total time taken to cover the particular distance. So that is 5,236 meters approximately. So to calculate the distance of one go from the surface of the sea towards the seabed, we'll half that particular distance or divide it with the factor of 2 as well. So the total distance covered is 5,236 meters. So when we'll divide it with the factor of 2, we'll get the answer, which is 2,618 meters. Okay, so that is the end of the numerical 11.7. Now I'm going to read the statement of the numerical